Okay, so we're going to do everybody's favorite word problems. Yay! Okay, so this is modeling with growth, decay, and compound interest. So I think in Math 1 you do simple interest, but we're going to do some compound interest, so different formula. Looks pretty scary, not that big of a deal. Learning target is I can model and solve problems using growth, decay, and interest. So here's the formula you may or may not remember from Math 1, but this is exponential growth. So it looks like this. F of t is your ending amount, equals A. A is going to be your starting amount. So sometimes you're talking about money in an account. Sometimes you're talking about like how much something was worth. That's your starting amount. In the parentheses, you're always going to have 1 plus R. R is always going to be a rate. You always need to change it to a decimal. So usually it'll be in percentage. Make sure you change it to a decimal or you're going to get the wrong answer. And then T is always going to be time. So that is going to be for when anything is growing exponentially, or increasing in value, or appreciating in value. Alright, so exponential decay, maybe you remember. F of t, same thing as that last one. It's going to be your ending amount. A is going to be starting amount. So the difference with this one is inside the parentheses, you're going to have 1 minus R. And R is still rate, and you're still going to change it to a decimal. So change to decimal. And then T still represents time. So that is exponential decay. If something is depreciating in value, if it's decreasing in value, if it's dying off, I don't know. Just pay attention to the words. Okay, so this is a brand new one. Oh, it's kind of rough. Alright, so this time when we say A, this is going to be our ending amount. Okay. So P is going to be your starting amount. Sometimes they're going to call this the principal amount, and they spell it like principal, like Mr. Beamer is our pal. I don't know why. I think it's wrong, but whatever. R is going to be rate. Still going to change it to a decimal. T is going to be time, like it always is. And N is going to be a little bit different. So N is going to stand for the number of times it's compounded in a year. For example, if the question reads something like you have $5,000 and it's compounded monthly, then your N would be 12 because there are 12 months in a year. If it says it's compounded daily, we're going to say 365. Let's assume it's not a leap year. If it's compounded weekly, that's 52. If it's compounded semi-annually, that means twice a year. People have argued with me. Another math teacher argued with me and said it was 6. No, semi-annually is twice a year. So that's kind of weird. Notice that the formula is P parentheses 1 plus parentheses R over N double parentheses, very important. And then to the power of N times T. So notice that N is twice. That is not a mistake. You have to write it both times. So there should be a number where all of these letters are. Okay. The only time that you're going to use this formula is if you see these words, compounded continuously. If it does not say continuously, then you use this formula over here. The only time you use this one is if it's continuously. Some people will call this the PERT formula. I don't know. You can call it whatever you want to. So A is going to be ending amount. P is your principal. That's your starting amount. E is the number E. It's in your calculator. So I forgot what it is. And you just use the button on your calculator. But if you have forgotten, it's like 2.71828, and then it keeps repeating on forever. Okay, R is rate. Change it to a decimal. Change to decimal. And T is time. And do notice that R and T are they're both exponents and they're being multiplied. So there's an understood multiplication. Don't just put two numbers right beside each other. That's crazy. Okay. Alright, so I think the hardest thing is reading a question and knowing which formula to use. So remember, use this one if it says compounded continuously. If it does not have the word continuously, then it's this formula. Use this formula anytime you talk about something depreciating in value, decaying, decreasing in value, and use this one anytime you're talking about something growing, or a word that makes you think of growth. Okay, so I want you to read this one. I want you to think about which one you think you would use. Alright. Nowhere in this question or statement does it say anything about compounded. So it's not those last two formulas. This one's talking about increasing in value. So we're going to use exponential growth. Okay. So Slate invested $5,000. That's my A. That's how much I started with. 1 plus. It's going to increase in value by 2.3%. That is a percentage. So anytime you want to change percentage to a decimal, you move the decimal over 2 places. So this is actually going to be 0.023. And then we're going to find the investment after 15 years. So that's our time. So time is 15. So all you have to do is type this in the calculator and make sure that 15 is an exponent. And because we're talking about money, we're going to round to 2 decimal places. So if I invested $5,000 into an account, after 15 years, I would expect to have $7,032.42. Okay. Slate took out $30,000 loan at 4% interest. Compounded quarterly. So there's that word compounded. It's not continuously, so we're going to use this formula. Alright. How much interest will she have paid after 12 years if the loan actually costed Slate $45,000? So go ahead and write the formula down. Alright, so our principal amount, we started out with $30,000. 1 plus. Our rate is 4%. I gotta change it to a decimal, so 0.04. It is compounded quarterly, which means 4 times a year. Double parentheses, number 4 again, and we're talking about 12 years. So go ahead and type that in your calculator and round to 2 decimal places. Okay. So here's how much it actually, my loan ended up being. Okay, so when you go get a loan, when they finance it, they add a little extra to it. So let's say the loan actually costed me $45,000. So we're going to subtract and figure out how much it cost me just to finance something. So what this means is if I go get a car and it costs $30,000, if I pay $30,000 like in cash, then I don't have to pay any interest. If I take out a loan for $45,000, well, let me say this. If I take out a loan, let's say the loan was for a certain amount, I'm going to end up paying so much extra just in interest to finance it. So I'm spending this much money just to finance that loan because I didn't have it in cash. That's what this question's asking. It's a little weird. Alright. So a baseball card was valued at $200. in 1980, it has increased in value. So it's not talking about compounded interest at all. So this is definitely exponential growth. And it's exponential growth because it says it increased in value. So we're going to do 1 plus r to the t power. So it started out valued at 200. 1 plus 7% is 0.07. And then time, you just got to think how long it has been from 1980 to 2016, and that is 36 years. So type that in your calculator, see what you get. So that baseball card is worth $2,284.79. Not bad. Okay, so a lot of times on the EOC and even on the ACT, they like to have questions like this. So how long would it take an investment compounded continuously? So this is the only time you use the PERT formula because it says compounded continuously. We want to know how long it will take to triple in value. So because it doesn't give us a starting amount, let's just say $1. So we're going to start off with $1. If we want $1 to triple, it needs to equal $3. That's how you triple a dollar. Alright, my rate is going to be 0.05, and I don't know my x value. So here's what we're going to do. We're going to clean this up a little bit. 1 times e is just going to be e to the 0.05x. And then, we've already learned how to do these. The way you get rid of like an e is to take the natural log of both sides. When you take the natural log of an e, it cancels out. So what we have is the natural log of 3 equals 0.05x. We got to get x by itself, so we're going to divide by 0.05. So in my calculator, I'm going to type the natural log of 3 divided by 0.05. So, sorry, I realized I started using t and then I switched to x. I do that sometimes. That was not meant to be confusing. So it would take about 21.97 years. Because we're talking about time, if you wanted to round that to 22, that's perfectly fine. So about 22 years to triple your investment. Alright. Notice this one says compounded bi-monthly. It does not say compounding continuously. So we're definitely not going to use this formula. We're going to use the other compounded interest formula. Okay, so P is what we start with, so 2400. 1 plus, my rate is 1.8, which I'm going to change to 0.018. My R is twice a month, so there are 12 months in a year. If it happens twice a month, that's going to be 24. Remember, double parentheses, 24 goes up here again, and then you're talking about 25 years. So go ahead and put that in your calculator. Alright, and you get 3,763.31. Okay, this one says compounded continuously. That's when you use the PERT one. Alright, so I started out with 2,658. E, remember, is that number E, is the button on the calculator. My rate is going to be 0.09, and I'm talking about 15 years, so you just type that in your calculator. So I got 10,253.04. Alright. So notice this one is talking about decreasing in value, and we're not talking about compounded interest. So this one is going to be, oh, let me erase that, sorry. This is going to be exponential decay, which is the time that you do the 1 minus r. Okay, so I paid $28,000. My rate was 14%, so 0.14. And I don't know my time, but I'm trying to figure out when it would be 5,000. So the first thing we're going to do is I'm going to clean this up just a little bit. So we got 5,000 equals 28,000, and I'm just going to go ahead and do 1 minus 0.14, which is 0.86. So you can see what we're doing. Okay, so I'm going to get rid of the 28,000. It's being multiplied, so I'm going to divide by 28,000 on both sides. That cancels out. And I'm going to use a lot of decimal places. You can use some more, even if you wanted to. So if you notice, this is an exponential. I know that because it's a number to an exponent. The opposite of an exponential is log. So I'm going to do is I'm going to change it to log form. It's going to be log 0.86 of 0.17857 equals t, and I'm going to type that in my calculator. And I got that it's going to take approximately 11.42 years. And I did it again. I always switch the variable because I'm just used to putting x forever. So t equals 11.42. My bad. Alright, this is our last one, yes. Okay, so Slate bought a new car. Notice it says depreciate, so it's that same formula we just used. Alright, so it started out with $28,000. Okay, still going to go down by 14%. And this year, it's just, it's talking about 3 years. How much will the value be? Just type that in your calculator. Alright, so after 3 years, we have lost a whole lot of money. Okay, so send me some questions. Do your assignment. Do it before Friday if you want feedback or if you want help or you want to redo it. Okay, bye.